Good morning, everyone. My name is Yawar Herekar, and today I'm going to begin by telling you a story. In October of 2013, Hurricane Sandy hit the east coast of North America, causing widespread destruction and power outages that stretched all the way till Michigan. Large sections of Lower Manhattan were also hit quite hard and suffered from power outages as well, all except for a few buildings that still had energy and were lit up. Those buildings were a part of New York University, and they were powered by a single self-serving power source. That power source was a smart microgrid and an example of a resilient system. Today, I'm going to talk to you about a bill that proposes such infrastructure at the local level, a bill that promotes not only resilient systems, but efficient systems as well, given the fact that 1/3 of all of the energy generated for electricity is lost in the form of waste heat. That bill is S.1205, the Local Energy Supply and Resiliency Act 2013. So the agenda for today is made up of 8 questions that I will answer with this final briefing. I will then conclude with what our next steps are and wrap up with a question and answer session. So what is the bill and what is its purpose? The Local Energy Supply and Resiliency Act 2013 was introduced in the 113th U.S. Congress by Senator Alan Franken of Minnesota. The purpose of the bill is the following: promote efficiency of energy generation and distribution, promote resiliency and reliability of local energy infrastructure, decrease air pollution and greenhouse gas emissions, reduce fossil fuel use and combustion. So essentially, this bill recognizes that there are environmental problems associated with energy generation and distribution. So how does energy generation lead to environmental problems? Energy generation is inherently inefficient. 36% of all the energy generated for electricity is lost in the form of waste heat. Waste heat is then released into the environment and is a major source of air pollution. So what does this mean to us? It means that in order to get the same amount of energy, we have to increase our fossil fuel use. Secondly, the system also leads to a lack of local energy resiliency, which in turn increases our vulnerability to natural disasters such as Hurricane Sandy. So then how do we reduce waste heat and increase energy efficiency? We can do this in 2 ways using technology. The first is through combined heat and power systems, and the second is through smart microgrids. So how does combined heat and power systems, how do they save energy? Well, they're the first technology that we will look at. As shown on the screen, this is a standard power plant with a fuel input of 100%. 40% of this fuel is converted into useful energy produced for electricity, while 60% of this is discarded as waste heat into the environment. Now, the picture shows a combined heat and power plant. This is a standard power plant. This is a combined heat and power plant with a fuel input of 100%. 40% of this fuel is converted into useful energy produced for electricity. 40% of this is recovered energy used for heating and cooling purposes, while only 20% is waste heat discarded into the environment. So how do smart grids save energy? Smart grids are the second technology that this bill promotes. Smart microgrids are computerized systems that are capable of measuring the supply and demand of energy. This allows the system to distribute energy flow during peak hours, off-peak hours, and power outages. Smart microgrids can also tap into multiple sources of energy, both renewable and conventional. So when renewable energy like wind and solar are available, they can use those. Otherwise, they switch on conventional forms of energy. And then when renewable energy becomes available again, they switch back. Another good point about smart microgrids is their proximity to the source of distribution. This helps in reducing transmission and distribution losses and losses in the form of waste heat. So now let's talk about the bill. How does the bill promote combined heat and power systems and smart grids? The bill addresses both of these scientific and technological solutions. Local energy systems, though capital intensive, provide a good return on investment over time given their efficiency. So to speed the investment process into such local energy systems, the bill mandates the establishment of a technical and financial assistance program. The bill says that assistance in the form of grants will be provided to identify, evaluate, and design local energy infrastructure. The bill also provides $15 million that will be available from the years 2014 to 2018 for feasibility studies and engineering design. The second part of this bill is a $4 billion loan guarantee program that will be added to the Energy Policy Act, and loans will be provided for the construction costs of local energy systems. So with that said, are there examples of combined heat and power systems now in use? Yes, there are. The Avedure in Copenhagen, Denmark is a very efficient combined heat and power system. It has a source of fuel to generate electricity and district heating. Not only does it do that, but it also recovers heat lost during energy generation to supply electricity and heat to its own facility. The extra heat generated is then sent out for district heating and cooling purposes. The Avedure supplies heat to 180,000 homes and electricity to 800,000 homes. So not only is the Avedure self-sufficient, but it's also very efficient, having replaced 3 older coal-fired power plants and consequently reducing carbon dioxide emissions by 10% per year. So with that said, are there examples of smart microgrid systems in use? Yes, there are. As mentioned in the story in the beginning, New York University has a smart microgrid which worked very well in a natural disaster such as Hurricane Sandy. New York University Smart Microgrid is made up of a 13.4 megawatt combined heat and power plant that powers the university's 26 electrically connected buildings and provides heating and cooling to 40 buildings. And it does this by harnessing waste heat. Also, it produces 30% less emissions than the oil-fired power plant it replaced. So in conclusion, what are our next steps? So far, we've looked at the science of the problem, and we've looked at the science of the solution. And we've also taken a deeper look at how this bill has a mandate to address both. In the fall, we will simulate the implementation of the bill and perform management analysis. So before the question and answer session, I would like to thank my teammates, my colleagues, for all of their hard work and their excellent presentations throughout the semester. Thank you, guys. I would also like to thank all the professors in attendance, especially Professor Cohen for his smart words and his guidance to us throughout the semester. And last but not least, I would like to thank all of you in attendance. Thank you, and please let me know if there are any questions.
Good job, Yawar. Do you have, are there any metrics or measurables for how adoption of this bill would affect, say, the levels of CO2 emissions in the country, a percentage or something like that?
Thank you for that question. We haven't really looked at those metrics yet because we were studying the science of the solution. I mean, I understand that the metrics do fall into that, but we're going to look at that during the fall semester when we look at the policy part of that.
Thank you for your for excellent presentation. But I have a question about the CHS application in Denmark you mentioned in your case study. There's a bulletin reduced carbon dioxide emission by 10% per year. So which year is the baseline? And I don't know whether it's reduce year by year by year, and all 10% by the previous year, all have the unified baseline?
Thank you, Dan. So the baseline for this year, it's a relatively new project, and it's replaced older power plants. The baseline for this year, I think, I'm not sure about that, but I think it's 2012, and so it's reduced. And of course, it won't continue reducing those, but it will reach a plateau. But it has significantly reduced carbon dioxide emissions.
So I think that's one question. Okay. We'll take one final question and then we'll move on.
Thanks, Yawar. That's an excellent presentation. I'm just wondering whether you guys have looked into what are some ways in which you can measure the success of this bill, whether it's by the number of smart grids that people or cities end up building, or is it by the uptake of the grants as such?
Thank you, Dennis. That's a good question. And it would be a better question if you asked that next semester, because we're not really, we're just looking at the science. So that falls in the policy part. But yeah, sure.
Okay, thank you.
Okay, thank you, Professor.